guys, welcome back to this channel. Nice to see everyone again. And for today's video, we'll talk about the chemical test of alcohol. And we have two chemical tests today. The first one is your Lucas test. The second one is your iodoform test. We are going to look at the function of the test and what do we use in the test and what would be the observation and also chemical equation. So let's start first one with your Lucas test. The function of Lucas test is to identify the classes of alcohol. We know that we have three classes of alcohol. We start off with your primary alcohol. We can have your secondary alcohol. And also last but not least, your tertiary alcohol. So the function of the Lucas test is to differentiate all the three alcohol over here. And the reagent and condition that we are going to use is your concentrated hydrochloric acid. Bear that in mind, your hydrochloric acid must be concentrated right now. And also your zinc chloride, your ZnCl2. And sometimes we need the presence of heat. So heat is an optional over here. It depends on your alcohol and also your Lucas reagent and also the classes of alcohol. Bear that in mind, this is what we call your Lucas reagent. So for Lucas test, the reagent and condition is concentrated hydrochloric acid, zinc chloride, and heat. Next, let's move to observation. What would be the observation when your alcohol react with Lucas? We know that the function of Lucas test is to differentiate the classes of alcohol. So, your primary alcohol, secondary alcohol, and tertiary alcohol should give you different observation. Let's start with the primary. When the primary alcohol react with the Lucas reagent, your primary will form no cloudy solution even after 10 minutes of heating. So, your primary alcohol require heating. And there will be no cloudy solution formed even after 10 minutes of heating. How about your secondary alcohol? In the secondary alcohol, you will have cloudy solution formed after 5 to 10 minutes of heating. So it can be 7 minutes, it can be 6 minutes, it can be 8 minutes, as long as you put a time over there. Alright, so for your secondary alcohol, you will have cloudy solution that will be formed after 5 to 10 minutes of heating. And you can see the differences between the primary alcohol and the secondary alcohol right now. Because your primary alcohol stated that there is no cloudy solution. But your secondary alcohol, there is cloudy solution. See the difference? Last but not least, your tertiary alcohol will also form cloudy solution. But what makes your tertiary alcohol different from the secondary? Your tertiary alcohol will be forming the cloudy solution immediately. Look at the differences. It's the time over here. Your secondary alcohol will form cloudy solution, but it will take about 5 to 10 minutes of heating. But for your tertiary alcohol, you will form your cloudy solution immediately. See the difference? So all this is the observation for the different classes of alcohol. In the other words, first thing before you answer the question is to know the class of alcohol. You must identify the class of alcohol before you proceed with your Lucas test because different classes of alcohol will give you different observation. Okay? And every single words that I have on the screen, including the time and the word heating, is a must whenever it is stated. And for the tertiary, the only keyword over there is your cloudy solution formed immediately. Okay? Simple. With a condition, you know the classes of alcohol. So make sure you can identify the classes of alcohol. Next, let's move to chemical equation. The chemical equation for your primary alcohol over here will be something like this. It's a primary alcohol because the carbon that holding OH is only holding to one R group. So this carbon is a primary carbon, therefore it's a primary alcohol. React with your concentrated hydrochloric acid with the presence of zinc chloride and also the presence of heat because you require heating. But there will be no reaction because there is no cloudy solution formed. So there will be no reaction. Next, you are having your secondary alcohol chemical equation. Let's look at it. This alcohol is a secondary alcohol because the carbon is bonded to 2 carbon group. So this carbon is a secondary. When the carbon that holding the OH is a secondary carbon, it will then become secondary alcohol. And in the secondary alcohol, you know that there is cloudy solution. In the other words, there is reaction happening. And the changes is definitely because of the presence of concentrated hydrochloric acid, zinc chloride, and also heat. And what is the changes? The changes is your OH will be then substituted by your Cl. You can see that the changes over here is your OH substituted by Cl. The Cl that come from the HCl. Alright, the Cl will go in and substitute the OH, and this is your alkyl halide that form, while your H2O will be produced as the byproduct. Just a kind reminder for your secondary alcohol that is heating. Therefore, in the equation, you also need to put down the symbol of heating. So your primary alcohol require heating, your secondary alcohol require heating. But in your secondary alcohol, that is cloudy solution form, so you must form a product, and the product is as simple as substitute the OH with the Cl from the hydrochloric acid, forming H2O as a byproduct. Simple, easy. Last but not least, for your tertiary alcohol, let's take a look what happened. So in your tertiary alcohol, the carbon that holding the OH must be a tertiary carbon. That's why you become a tertiary alcohol. You can see that when the carbon is attached to 3 alkyl group. So that is your tertiary carbon, become a tertiary alcohol. React with concentrated hydrochloric acid and zinc chloride, and I hope you realize that there is no heating because your cloudy solution form immediately. No heating required. And what is the changes? Your OH will be substituted by the Cl that coming from the HCl, forming this product. And also, the hydrogen from the HCl will be combined with the OH, forming H2O as a byproduct. So your cloudy solution over here is actually this alkyl halide. So your cloudy solution is actually this alkyl halide. Okay, simple, easy. Just some extra knowledge for you guys. The alkyl halide that you form over here cannot dissolve in water. So when it cannot dissolve in water, you will have another observation, which is 2 layers solution. But why the alkyl halide cannot dissolve in water? Because your alkyl halide cannot form hydrogen bond with water molecule. Alright, so bear that in mind, this alkyl halide, alright, is insoluble in the water. Therefore, you will have another observation, which is 2 layer solution, but this is not the main observation. But the question can ask, and therefore I give you some extra knowledge on here. They cannot dissolve into each other because alkyl halide cannot form hydrogen bond with the water molecule. Make sense? Simple. Next, the biggest problem will be how to answer in the exam. Like previously, it's a chemical test, therefore the easiest way will be a table. The first thing that you must put down in your table is the name of the test. The second thing definitely will be the reagent and condition based on the chemical test that you choose. Third, you must have the compound of your alcohol down. At the same time, you must also classify the alcohol. You must know that your compound is a primary, secondary, or tertiary alcohol. Next, after you know the class of the alcohol, you can write down their observation according to the class of the alcohol. Last but not least, based on the observation, you can have the chemical equation down. So, how do you answer in the exam? Is definitely using this table. And the most important thing is to classify your alcohol, knowing whether they are primary, secondary, or tertiary alcohol. That is the most important thing before you answer the chemical test of alcohol. Alright? Next, let's try some example. The question says, suggest a chemical test to differentiate propanol and 2-propanol. And the first thing, what do? you need to know what is the class of this alcohol and what is the class of this alcohol. And how do we know the class? What would you do to know the class of alcohol? Simple, draw them out. So you started off with your propanol. Your propanol is a 3-carbon alcohol where the OH is located on the first carbon. So your propanol will look something like this. While your 2-propanol will be a 3-carbon alcohol where your OH is located on the second carbon. So it will look something like this. And after you have drawn the propanol and the 2-propanol, what do you do next? You classify the alcohol. By looking at the carbon that holding the OH, the carbon in the propanol is a primary carbon. Therefore, your propanol will be a primary alcohol. While your 2-propanol, look at the carbon that holding the OH. The carbon that holding the OH is a secondary carbon. Therefore, your 2-propanol will be a secondary alcohol. Simple. And then only you put into the table with the name of the test, the reagent, draw your compound, state the observation, and the chemical equation. So, let's start with the table. Having the name of the test. So the name of the test now is Lucas test. The reagent and condition that we are using is your concentrated hydrochloric acid. Make sure you have the word concentrated down. Zinc chloride and also heat. So for the compound, you can write the name and also draw the structure out. So when you draw the structure out, you can clearly see what class is the alcohol. So classify it straight away. That is your primary alcohol. While for the 2-propanol, put down your 2-propanol. Draw your 2-propanol. You know that your 2-propanol looks something like this. And classify your 2-propanol, which is a secondary alcohol. Then we move on to your observation. Knowing that your Lucas test in your primary alcohol right now, what is the observation? No cloudy solution form even after 10 minutes of heating. So you must have every word down, including the no cloudy solution, including the time and also the word heating. While for the secondary alcohol, what is the observation in Lucas? For the secondary alcohol, there is cloudy solution. So cloudy solution form after 10 minutes of heating. Exactly the same thing just now, where you have the word cloudy solution, the time, and also the word heating. Simple. It is simple when you know the class of alcohol. So it's very important to identify the class of alcohol before you write the observation. Okay? Last but not least is the chemical equation. So the chemical equation for the propanol will be no reaction because there is no cloudy solution. Therefore, the equation will be as simple as this. Plus concentrated HCl with the presence of zinc chloride and also heat, there will be no reaction. While for the secondary, which is your 2-propanol, your equation shall look something like this. Starting off with your 2-propanol, reacting with the concentrated hydrochloric acid with the presence of zinc chloride and also heat because it's only a secondary. And what would happen is your OH will be substituted by the Cl and also forming a byproduct H2O. And that is your chemical equation for your 2-propanol, which is a secondary alcohol in Lucas. Simple. So bear that in mind, the only changes that happen is your OH substituted by Cl. That is the only changes that happen in your Lucas test and produce the byproduct H2O. Okay? Alright, simple. As long as you know the class of alcohol. then everything will be simple. Therefore, make sure you can draw your alcohol when the question gives you the name. Alright? Draw the alcohol correctly. Identify the class of alcohol correctly before you proceed with the chemical test. Simple? And that is all about Lucas. Next, we shall move on to your second test, which is your iodoform test. So the next test and also the last one in this video is the iodoform test. Iodoform test, the function is to identify the methyl carbonyl group. And the question over here is, what is methyl carbonyl group? Just a kind reminder over here, your carbonyl is actually the carbon that holding the OH. So this is the carbonyl carbon. So methyl group, we know that methyl is a CH3. So what is meant by identify the methyl carbonyl group? The methyl carbonyl group that we want to identify is as simple as the carbon must be holding at least one OH. The carbon must be at least holding one CH3. The same carbon must also at least holding one hydrogen. So this is your methyl carbonyl group. Alright? Your methyl carbonyl group must be the carbon holding one OH, one CH3, one hydrogen. This is the carbon that we are looking for. And this bond can be anything. Alright? This bond can be anything. It can be your R group, no matter how many carbon R group. Okay? The only thing that we focus on right now is the carbon that holding your OH, which is your carbonyl carbon. Make sense? Don't worry if you cannot see it now, we will look at the example later on. Next, the reagent and condition that we use in your iodoform test is your I2, your iodine, in an alkaline condition, NaOH, with the presence of heat. So you must use I2 and AOH and also heat for the iodoform test. This is the recipe. Next, what would be the observation? The observation is your pale yellow precipitate is formed. What is actually pale yellow look like? That is your pale yellow. Alright? And this pale yellow is actually your triiodomethane. And your triiodomethane is written as CHI3. And this is your pale yellow precipitate, because your CHI3 will become a precipitate, alright? And this is the pale yellow precipitate that you will form in your lab. So remember, it's a CHI3, alright? It's a triiodo over here, so that is 3I. So it's a CHI3, okay? Be careful when you write this triiodomethane. Next, let's look at the chemical equation for this iodoform test. So the chemical equation will look something like this. Bear that in mind, the methyl carbonyl group that we want to focus is the carbon that holding the OH. The same carbon must be holding hydrogen and also CH3. This is the methyl carbonyl group that we are looking at. Will react with I2 with the presence of NaOH and heat. And what will happen and what will be the changes? The first changes is the CH3 will be removed. Alright? You must remove the CH3. What do I replace when I remove the CH3? Simple. Your R remain unchanged over here because that is not the thing that we want to look at. The carbon that holding the OH right now loses the CH3, replaced by O-. Next is the OH and the hydrogen. The OH will also be removed. The hydrogen that attached to the carbon will also be removed and substituted by double bond O. So this is the product that you will be formed. Next is the byproduct that you will form, which is your pale yellow precipitate. Your pale yellow precipitate is your CHI3, and this is your pale yellow precipitate. Alright? So look at the changes again. The changes is your CH3 over here, remove, replaced by the O-. Alright? Next is your OH, remove, your H, remove, And both of them will then be replaced by a C double bond O. That is the changes. And your byproduct over here is your CHI3, which is your pale yellow precipitate, which is your triiodomethane. And to complete your answer over here, the NaOH that you use over here is actually sitting here. It's your O minus Na plus. But this is an optional. You can have it down or you can ignore it. Okay? It's not important over here. The most important thing is the changes that happen to your methyl carbonyl group, which is your C double bond O minus. This ion is your carboxylate ion. Alright, your COO minus. Simple. And that is iodoform test. Just make sure one thing, the carbon that holding the OH must be holding a methyl group and also a hydrogen. Another bond can be anything. Alright, just make sure you have this group. And also make sure you know what happened to this group of methyl carbonyl after it undergo iodoform test. Your carboxylate ion. Okay? Next, let's try to write some complete chemical equation for your iodoform test. So, this is my alcohol. We only focus on the carbon that holding the OH. Make sure this carbon holding one CH3 at least and also one hydrogen. So this is the group that we will be look at. And for your iodoform test, you'll be using your I2, OH minus, and also heat. And the group that doesn't undergo any changes shall remain. So you have your CH3 bonded to the carbon. So this is the carbon that holding the OH. And what happened is the CH3 right now is removed, substituted by O minus. Your OH and your hydrogen removed, substituted by double bond O. And also forming a byproduct of your CHI3, which is your triiodomethane, your pale yellow precipitate. And that is how we write the complete chemical equation of iodoform test. Simple, easy. Another example. Again, we focus on the carbon that holding the OH. Make sure this carbon holding at least one hydrogen and also one CH3 group. So this is the group that we are looking at. And to undergo iodoform test, you need to have the presence of I2 and AOH and also presence of heat. And bear that in mind, the group that doesn't involve or will have no changes, just copy the group back. And this carbon right now bonded to the carbon that holding the OH. And as we all know, CH3 will go out, replaced with O minus. The hydrogen and the OH will go out, replaced by double bond O. So that is your carboxylate ion. Alright, your COO minus. Plus with the byproduct CHI3, which is your pale yellow precipitate. Simple. And that is your equation for iodoform test. And in this example, what I'm trying to show you is the group back there has no effect at all. So whatever the group, you just copy back. Because your iodoform test have no changes towards this group. Alright, what we focus on is only the carbon that holding the OH. Ensure the carbon having at least one hydrogen and also at least one CH3 group. That is the only group that we focus on. Okay? Simple. Next, and also last but not least, you have a carbon that holding the OH group. You have a CH3 group. But is this carbon right now positive iodoform? Will it react with the iodoform reagent? No, because there is no hydrogen. When there is no hydrogen, when it reacts with your I2 and AOH heat, what will happen, guys? There will be no reaction. Why there is no reaction and no pale yellow precipitate? because the carbon that holding the OH only have one OH, one CH3, but no hydrogen. Bear that in mind, your methyl carbonyl group must be a carbon that holding OH, holding hydrogen, holding CH3. That is your methyl carbonyl group. So it must have at least one hydrogen, one CH3, and one OH. Then only it can become positive iodoform test. Make sense? Simple. Next, let's look at some example. Suggest chemical test to differentiate 3-methyl-2-butanol and 3-pentanol. So the first thing is you must draw this alcohol and also this alcohol. You must draw them before you do the iodoform test so that you can check whether they have the presence of your methyl carbonyl group or not. Right? So draw them out. So 3-methyl-2-butanol is your 4 carbon, holding OH on the second carbon, holding methyl group 1 at carbon number 3. 1, 2, 3, 4. So carbon number 3 holding CH3. Complete the structure with hydrogen. Make sure every carbon deserves a 4 bond. So that is my 3-methyl-2-butanol. How about my 3-pentanol? So pentanol is a 5 carbon, where pentanol right now, the OH is located at the third carbon. Complete every carbon with enough hydrogen. First and foremost, try to classify them first. So this carbon right now is what class? It's a secondary carbon. Therefore, it will be a secondary alcohol. Check this carbon. This carbon right now is also a secondary carbon. Therefore, again, this guy will be secondary alcohol. The class of alcohol right now is the same. So can we use Lucas test? We cannot use Lucas test over here because the class of the alcohol is the same. That will give you the same observation in Lucas test. Therefore, we cannot use Lucas test. And we only have 2 tests. If you cannot use Lucas, you must use iodoform test. And iodoform tests have their requirement. You must have this methyl carbonyl group. So this methyl carbonyl group first focus carbon that holding OH. So let's check for your 3-methyl-2-butanol. Carbon that holding OH must be at least holding 1 hydrogen. And also must be at least holding 1 CH3. So this guy having the methyl carbonyl. How about your 3-pentanol? So this carbon is the one that holding OH, having at least 1 hydrogen. But is this carbon right now holding any CH3? No, we don't have CH3. When there is no CH3, this guy will be negative towards iodoform test. So, one will be positive, one will be negative. Therefore, iodoform test can be used. And as always, you answer your chemical test in this table, where you have the test name, the reagent condition, the compound, the observation, and also chemical equation. So let's look at the complete answer. First and foremost, you start with the test name. The test name that I use today is my iodoform test. Next, your reagent and condition is your I2 and AOH and also heat. Next is the compound. The first compound that you have is your 3-methyl-2-butanol. So your 3-methyl-2-butanol should look something like this. And do we need to classify the alcohol over here? You can classify, but it's not necessary. So you know that this guy is a secondary alcohol. Next, you have your 3-pentanol. So have your 3-pentanol down and draw the structure. And your 3-pentanol shall look something like this. And when you classify this alcohol, you realize that it's again a secondary alcohol. That's why you cannot use Lucas test. You must use your iodoform test. And as we agreed just now, your 3-methyl-2-butanol will have your methyl carbonyl group. Over here, we don't have methyl carbonyl group. Therefore, the observation for your 3-methyl-2-butanol under iodoform test will be pale, yellow, precipitate, form. While for your 3-pentanol will be no observable changes. Means that you don't see any observable changes. And the most important is there will be no pale yellow precipitate. Alright? To make it easier for you, you can just write no observable changes. Next, go into your chemical equation. So for your chemical equation, draw your structure out. Expand your structure a bit so that you know which carbon you are looking at. Reacting with the presence of I2 and AOH and also heat. And what is the product? You know that the CH3 will go out replaced by O-. You know that the hydrogen and the OH will be go out replaced by double bond O. And then the rest of the thing back there, just recopy. And the most important thing is your observation. Your observation over here is your CHI3 precipitate. Alright? Don't forget this. While for your 3-pentanol, there will be no observable change because there is no changes. So for the 3-pentanol, when it reacts with your I2 and AOH and also heat, there will be no reaction. Why there is no reaction? Because the carbon that holding the OH don't have the methyl group. While over here, the carbon that holding the OH having one hydrogen, having one methyl group. That is your methyl carbonyl group. Always remember your iodoform test is to identify the presence of your methyl carbonyl group. The carbon that holding OH, hydrogen, and also CH3. Simple. Just make sure you remember your CHI3 as your pale yellow precipitate in the positive iodoform test. Alright? Easy. And I think that's it for this video. Simple. We have two chemical tests over here, your Lucas and also your iodoform test. Both of the tests are having different function. And I hope this video helps you to understand these differences between the Lucas test and also iodoform test. And if you still have any question, feel free to ask me in the comment below. And I'll get back to you as soon as I can. And if you like the video, don't forget to hit the like button and also subscribe to my channel for more video. Thank you for watching and I'll see you in the next video.